right, so what do we want to achieve? So you definitely don't need the practical equipment to practice the commands. You can do that on Packet Tracer, but the practical equipment is there so you can actually know what to expect on the day when you do your exam on the practical equipment. I've sort of been harping on that a little bit because in real life, when you get a job and you're doing this, you're not doing it on a simulation. You do it on the real network equipment. So regardless of what cloud computing they are and all those kind of things, you still need network infrastructure to connect to that cloud. And that's where these routers, switches, etc., physical equipment is always going to be there. Okay, it's the physical equipment that's going to be there to implement any software-defined services. So if I just drag a couple of routers, okay, it doesn't matter which model. The models in the cabinet, it's going to be different to the models maybe here. But it doesn't matter because the beauty of Cisco is that it's consistent iOS, the operating system. So I'm just going to drag a couple of devices just so I can give you a picture of what we want to achieve. All right, so basically we've got, if you look at the physical equipment, you've got a whole bunch of PCs there. Okay, they're going to be these two PCs. In the cabinet, you've got switches, you've got routers, and in this case, we're going to have 2 routers, 2 switches. Okay, so if we like to think of it, that's almost split in half, isn't it? All right, so this is a simple setup, not too complicated, and let's just connect it up. So for example, from PCs to switches, we use a straight through cable. So we just go here, there's a fast Ethernet. We'll go here and we connected. I always like to connect the router to the first one, okay, the devices to the first one. So this is a PC, so I'll connect it to the second one. And again, on the router, we've got gigabit. Okay, I always like to start off with the first one, the lowest one number, and I connect it to the first one here. So I like to keep the equipment, it's just me, okay? It doesn't matter which one you connect it to, as long as you configure the right interface in the command line. So same thing over here, so I might do it the opposite way, probably is easier. Router to switch, straight through cable again, PC to switch, fast Ethernet. Okay, between the routers, we're going to, in the real life, going to use a serial interface. So in this packet tracer, you'll see that when we click on it, we can see the physical layout. You can see there's a light there. Okay, that light there is actually means it's powered on, just like a real device. So before we can actually add anything, we have to power it off. Funny, isn't it? It's a simulation, but it's even simulating. It's even simulating that part of it. So bear with me. Let me just drag this across. So we have to turn it off before we add so you can see there's a couple of holes here. They're basically holes for you to add expansions. And basically the serial we're going to use is this plate here. So we'll put it on the left to right, the first one. Okay, so I always like to start with the first one, then work our way up to the other one. So I can even do more. I can drag another one here if I wanted to, but let's just leave it simple. Okay, and a real life router, it will be already configured how it is. You're not going to change the physical configuration, so you just have to recognize on the label what it is. So if we zoom in, you can see that that is serial. It's a serial 0, it's a serial 1, so from top to bottom, and there's a couple of link lights there. So once we plug this in, we can just power on, and we'll go to the other router to do the same thing. All right, so we'll close this one. We'll do the same thing with this one. So again, we're going to power off. So we'll zoom in first of all, power off, and then we're going to select one of these serial and we'll put it in there. Because until you put that in there, you can't connect the thing up with serial cable. It's like it doesn't have that interface. So these HWICs are basically expansion cards, if you like, in the computer. Routers are just computers. You're just adding different types of network cards here. Okay. So once we have that, so between a serial cable, we need to use this serial connection. And you might notice that I clicked on the one with the clock symbol. Remember we talked about the clock rate? Okay, the clock rate, yeah. So remember the DCE? So remember that if you connect this side up, that means that the first connection is going to be the DTE. If you click on this one, this means the first connection is going to be the DCE. Remember the importance of the ends? You set the clock rate on the DCE end. So that's why this one represents the clock there. Okay, so I'll click on this. And in this case, again, following my convention of smallest to largest, I'm going to go smallest first, it's router 0. And I'm going to go serial 0010. So I actually got the other thing wrong. So I put it on the wrong one. I should have started from the other side. But it doesn't matter. We've got it connected. And like I said, in real life, it's wherever it's on there. You just have to recognize what it is. So you notice that these ones are green and these ones are red. Okay, so if they're basically link lights. So they're basically link lights. So this means that this link is working and these links are not working. Okay, so let's just do some basic configuration. This is PC. This is not how you really configure an IP address on a computer, but this is how we do it in Packet Tracer. We go to the global settings, we configure a gateway. So before we even do that, let's actually take a print screen of this because I don't know how to put labels in Packet Tracer. I think you can. No, I don't know. Instead of working out how to do it right this second, I should have thought about it a little bit later. I'll just put it in here and I'll put some labels in, okay? So basically, if I actually go here, we're going to make this network here. Let's make it the blue network. And then we'll make this other network the red network. Doesn't matter what color, it's just as long as different. And obviously we got this network in the middle. Actually, we might make this the green network and we'll make this connection in the middle. So don't forget there's 3 networks here, isn't there? You all recognize that there's 3 networks? All right. And we'll make this network the red network. Okay, so in all reality, this is a LAN. This is probably something that's not akin to a LAN. So we'll just put some labels there. So what we're going to do is we're going to make this 192.168.10.0/24. We'll just make that a little bit bigger so you guys can see. All right, let's make it a little bit bigger so you guys can see. So /24, so it's a class C with a /24. Everyone should be familiar with that. We'll make this the blue network. On this other side, we'll make this the 192.168.3.0/24, and we'll make that the, all right. Paint is not the best. Okay, so let's actually make this the green network. All right, so and then finally leaves us with the red network. So we'll make this the 192.168.20.0/24. I'm just giving these arbitrary numbers. You would have to use whatever number you are given in your scenario. Okay, it doesn't matter what the numbers are. We can just implement the IP addressing. All right, so I'll just make that a little bit easier to see. Maybe you guys can see all that, okay? All right, cool. So we've got that. So we've got to give some IP addresses now. So by convention, the router is going to be .1, isn't it? So this interface, I'll just write it down here. We'll just make it black. What's the IP address of the router interface on this interface? Yeah, on this one here, right here.
192.168.10.
Correct. Okay, /24. So that's the route interface here. So I'm just basically setting the scene of what we want to achieve at the end of the day. So hopefully you guys can read that. Can you? Yeah, we might just make this a little bit smaller. It's not as important, so let's make it 10 size. And we'll put it right here. So this, the switch, I think we mentioned something about VLANs and IP addresses last week. So we want to make it the second IP address. Just say that's our rules, okay? So we'll make it 192.168.10.2/20, not 27, 24. And here we'll make this one. Let's say our convention is that we start the IP addresses for the clients, the host computers, the client computers, from 101 onwards to the rest of the subnet. So let's just say that's our rules, and we'll do that. All right. So that means if we go here, this is going to be 192.168.3.1/24. It's sort of a mirror, isn't it? And this is going to be 192.168.30.2/24, and finally 192.168.30.101/24. All right, and that's what we want to achieve. Sorry, these interfaces here. So we put /24, but realistically in real life, that's probably going to be /30. If you remember, /30 means there's only 2 IP addresses. That's all we need, 1, 2. So really, I might just really delete that. And how do we? Yeah, we'll delete that. We'll make it a little bit more realistic. Now that I think about it, so I'm doing this on the fly a bit. So excuse me if my planning is a little bit off, but I'm trying to apply the rules as I remember them. So really, this network is going to be 192.168.20.0/30, which means there's only 2 IP addresses. Okay. So everyone understands that? Yeah, okay, well, good. So now we'll go and put an IP address on this one. So I'm starting from left to right. So that one's going to be the first one, 192.168.20.1/30. And we'll make this a lot smaller. And we'll make it black. And we'll put it over here a little bit so I can have room to put this one over here, 192.168.20.2/30. And we'll move it right here so we can all see that. So that's what we want to achieve. All good with that? Any questions so far? Free networks, free broadcast domains, IP addresses for the things we just following our rules. Okay, obviously if you get different rules in the test, you read them, you follow them. Okay, so I'm just making up rules as I see fit. I'm just going to put this on my other screen so I can refer to it as I'm doing the configuration. Okay, so if I go here, first thing I can do is so this is not how you do it on Windows, but everyone should know how to configure IP address on Windows. Okay, so the gateway, if this is actually the display name, let's bring this back. Let's just give ourselves a little bit of a scenario. Let's just say if this is TAFE SA, let's just say that this is the Adelaide network. Okay, and this is the Elizabeth network. Is that okay? So this is actually a situation scenario is that we're basing on the TAFE campuses, and the 2 TAFE campuses are connected by this super long serial cable, basically. Okay, it's imaginative, but let's just say that's the scenario. All right, so if we do that, so we're going to call this instead of, so this is not how you do it on a computer, but this is as far as we can do it on this packet tracer, ADL PC, and the gateway in that case is going to be the Adelaide gateway, right? So 192.168.10.1, wasn't it? We don't have a DNS server in this situation. If we did, we would put it in, but we don't because that simple diagram does not contain any DNS servers. And then IPv4, so that was a 192.168.10.101 according to our plan to Class C, so I'll get a Class C subnet mask. All good for now. Same thing over here. This is going to be the Elizabeth ELZ PC. Okay. And then the gateway is going to be the 192.168.3.1. So far, so good. And we're going to give it a static IP address of 192.168.30.101. All good. Just make sure you ask questions if you see something I'm doing that you're not right. So maybe the first thing we'll do is we'll actually hook up. If you are on the real, so I'm going to show you the real one in a second. I just want to show you what we're doing here, and then we'll show you on the real thing. So this green thing, this blue thing is a console cable. So what we do is we plug it into the serial port, and obviously modern PCs don't actually have serial ports, but we have this USB adapter that plugs in to the console cable and then to a USB port. So we plug into the switch and we plug into the console port. Okay, so it's all color coded. It's very hard to miss. It's actually light blue, just like the cable. And now if we actually go to the PC, we go to the desktop. It's just like if we booted up the computer and we've got PuTTY or some other terminal program on there, we can actually set the baud rate, which is the bit rate, sorry. That's how many bits per second. And we click OK. It's basically going to give us entry to the thing. Okay. So remember, can you guys see this okay? If you can't, come closer, because I don't know if I can make this bigger. So come closer if you can't see it. Just go right up. This is a small class. Let's go right to the thing, okay? So if you remember, this is in what's called normal mode, okay? So remember, we need to be in the privilege exec mode. So the command to do that is enable, and there's no password set right now. So the first thing we want to do is just give it a host name, so we don't get confused. So host name is going to be ADL switch. Okay, so I might even make an obvious ADL Adelaide switch. If we have more than one switch, we might call this ADL switch 1. Oops. Oops, sorry. Oh, yeah, sorry. Configure terminal mode. Okay, so configure your terminal. Sorry, any configuration do you do in configuration terminal. So then it's the host name. Oh, I can't. Host name ADL-switch 1, and that's it. Okay, so any configuration you do is in the configuration terminal mode. All right, so the other thing we want to do is, remember we said that the switch, there's not much to configure, but if you want to actually be able to communicate with it remotely instead of with a console, we actually give it a VLAN and then an IP address, okay? So in this case, we're going to go interface, okay? So we specify which interface we want to configure in the configuration terminal, and it's going to be the VLAN interface. So VLAN, if I'm not sure, I just press tab, V tab, and then it'll tell me what I can do. Then it's the VLAN ID, so I'm going to call it 1, okay? It could be any number, really. This is the VLAN ID 1, and I'm going to go and enter this interface. And then to set an IP address, funny enough, and we said it was going to be .2, wasn't it? 255.255.255.0, and that was the subnet mask. And that's set, and we do a no shutdown. And the no shutdown turns on the interface. Okay, so if we actually press exit, we can get out of this. We can keep on pressing exit until we're out of it. We can use the show command, show IP interface brief. And basically we can see, if we scroll down, there's more. So you can see there's a VLAN, is that it's up. It's up, sorry, it's yes, it's up, okay? And obviously we can go and test this now. We've got two devices with IP address. What's the command that we can test connectivity? Yeah, so we'll go onto this PC, we go to the command prompt, and we ping 192.168.10.2. If you remember, that was the switch's IP address. And let's see what happens. Yep, there we go. Okay, so the first one's missed, possibly because of the ARP that we talked about before, but then it's getting a reply. This reply means there's connectivity. It means the cable and everything in between is correct, plus the configuration is correct. I might just close this door now. So that's so far so good. So you know what? We're done with the switch. We could configure the passwords and stuff like that. That might be a part of the next thing, but I'm just going to do that on the router, and that's the same demonstration anyway. So in real life, I'm not going to just get another console cable and I've only got one of these. You're going to get one of those, okay? Because each person is going to get one, and basically they just unplug it from the switch and they plug it into whichever device they're doing configuration. And if I go to this router now, I'm going to plug it into the console, and guess what? If I go here and I go up to the terminal and I click OK again, it's going to go to the default getting started configuration. So do I want to do it with the wizard? No. All right, so first, same thing, get into enable mode to, you notice I didn't have to type the whole thing. As long as I type enough that it recognizes that's the command, then I can enter it. So I get into enable mode and I'll go to the configuration. So that's something I missed last time. Got too excited with my demo and totally missed that one step. So if I want to do any configuration, it's a configuration terminal. So first thing is the host name is going to be ADL-router1, okay? Just our naming convention. We said there was two interfaces, right? So if we're not sure about this, if you remember that, if this cable, so this cable, if we're not sure with this cable, so if I press delete, no. So let's go to this cable. If you weren't sure, if you remember that was gigabit 00. So in real life, you'll be able to just see where the cable is plugged into and read the little label next to it. This is just the next best thing on here. So if I go back here, if you remember, it was gigabit 00. Okay, so same way of configuring the IP address. We don't need to create a VLAN this time because it's not a switch. So we just go to interface. Oops, not typing. Okay, interface gigabit. So you notice I'm using the tab completion. 00 is the first one. I'm in it. IP address 192.168.10.1, 255.255.255.0. Enter. No shutdown. Okay, so again, if we minimize this, you can see that, oh, that's green now, isn't it? By doing the no shutdown, it's actually turned it on. And this is orange, and that's because the switch is learning the MAC addresses. Remember the MAC address table? So it's learning that. So it's just like when we talked about when we first plug it in. So let's actually go back here, and there's a couple of other things we want to configure, isn't there? So let's actually configure. So we're still in the interface. You notice that it says configure if, that stands for interface. So we'll just exit out of that particular interface. We're back into the configuration mode. And let's see, what else do we have to configure? We have to configure the host name. We've got to configure the password, enable password, all those kind of things. So let's just do that. So enable secret is the enable password. And I'm going to set it as password 1. Okay, so it's whatever your standard is for your company. For this, I'm going to set it as password 1. No problems. Okay, and also we want to configure the console password, right? So line console. That's basically if I connect it with that blue cable, I need a password to go in. That's just physical security. Okay. Otherwise, anyone could just go in and wipe your thing. Line console 0, there's only one of them. So there's only one console port. So we just specify 0, which is the first one. IT, everything starts with 0. It doesn't start with 1 like your normal number. It starts with 0. That's the first number. Line console, and we go password. We'll call it password. No, we won't call it password 2. That's just too confusing, isn't it? What's another password that we can use? Okay. Key. Okay, we'll do something different. We'll do a pass WD 1. Okay, is that okay with everyone for demonstration purposes? It's password 1, but it's a different way of doing it, so we keep it consistent because this is only practice. Password 1, and then we require login. Remember? Did we type that before? Login. Did I type login already? All right. So, and if you remember, I'll exit this now. And the other one was the remote terminal, right? Remote terminal, the telnet, the SSH, and all that. Sorry. Yeah, VTY. You're right. Virtual teletype. Okay. So it's line VTY. And you can have multiple connections to VTY. So there's many people can be connected at the same time. So it's 0 to 15. So everything between 0 and 15, basically, that's what's saying. And we'll make it the same password. Okay. So pass WD 1. Okay. So we could do it password 3 or whatever, but it's the same password. And we require login. Okay. And then login. Okay, so it wasn't enough for me to be able to complete the command.
Blocks.
Yeah, it could be something else. There could be many commands that start with the LAG. Yeah, okay. I don't know what it could be, but it just wasn't enough for me to be able to complete it like that. All right, so we said that it was going to be SSH, right? So we're going to be transport input, going to be SSH. So we're just going to restrict it to SSH. All right, so we'll exit this. And what else? We've got to encrypt the password, right? So we can use the show command, show running configuration. Remember, it's not in the startup yet because we haven't saved it. This is in the configuration. Remember, we said that we do the configuration in the configuration terminal, but we do the showing of stuff outside of it. So we show the running config. And if we scroll down, you can see that the host name is okay, but enable secret is already encrypted. It's basically everything. Okay, here it is. Look at this. That's in clear text, isn't it? That's in clear text. That means if someone could potentially just read your password out of your configuration file if they had access. So we're going to go configure T again, terminal, and we're going to start a service called encryption. Password encryption, that's right. Password encryption, that's right. So you guys did learn something, so good work. All right, password encryption. So let's get out of this again. And let's do the same command as before. It's not letting me. Show running config and enable secret, still good. And you notice that the password now, it's not that password anymore, is it? Because it's being encrypted. That's the whole point of it. All right, so we've done we've done the gigabit network. We've done the passwords. But we haven't done the serial connection. I left that because it's a little bit different to the other one because, like I said, on this router, it is the DCE end. That means the clock rate must be set here. So we'll go to config terminal again. And, sorry, configure terminal. That's right. Interface. Interface, again, if I'm not sure, I go here. And what was it? 010, okay? So again, in real life, you would just read it off the back. Interface S serial 010, okay? Enter. First of all, IP address, not IP config, IP address. And that was 192.168.20.1. 255.255.255, and what was it? 250? Yeah, the /30 is 250, isn't it? Yeah, I think so. /30. So that was the last two octets, which is 252. 252. Okay, /30. Remember, we said it was going to be /30. You get me? Okay, /30 means if you use 30 bits for the IP address, 30 bits for the subnet mask, it's basically if you convert it from to a binary number to a decimal number, it should be 252. So if I wasn't sure, why take the risk? Why take the risk? We can just use the view scientific. And then we go 252, and we go, it's not scientific, it's programmatic. So 252, 2, and then if we look at the binary, that's two bits left, so which is /30, isn't it? Normal is /32. 252 is correct. So we'll press enter. Don't forget the no shutdown. Oops, yeah, no shutdown. I think I might have, sorry, we were talking about the clock rate. So I think I might set that first before I tell it to turn on. That's probably a good idea. So remember like your old day modems? It's basically specified in speed. 5600 is basically 5,600 bits per second, 56, sorry?
Just a question
Yep.
with that. With pre-exam and what have you, are we supposed to know all the clock rate settings?
No, yeah, you just have to set a speed. You will just set a speed. Yeah, it doesn't matter what speed, as long as there's communication. Or you can try. But I would stick with the binary numbers if I were you. Okay, 5600 works. Oh, sorry, no, 56. All right, that's better. So you can see one's not going to work. All right, you can test it out, but one's not going to work. It's 56,000, so it's like 56K modem if you remember back in the day. All right, so no shutdown. All right, it's changed to down. Ooh. Can you guys think of a reason why this is not green straight away?
The upside is not.
That's right. Okay, so even though I've done everything I need to do on this side, the other side is not done. Yeah, it's not communicating. So what we'll do is, again, we'll take this off and we'll go reach over all the way there because we can, okay? Basically, it's not like it's a physical different location.
Yeah.
Yeah, so if we go here, we might have to close it and reopen the terminal. And we'll go no to the initial setup. And we won't go through the whole thing about the configuring the password and stuff because I've already shown you that. It's the same way, okay? What I will do is I will set a host name though, because I just don't want to be confused. That's the thing I recommend, that if you do come do the practical, there's going to be 2 other groups. So it's going to be a little bit confusing for you. I would suggest you identify which ones are your routers with a sticky note. Just tape it on the thing.
I was going to ask.
Yeah, you can definitely do it. Don't make it something that's permanent, okay? Not permanent marker. That's just like this poster pads, okay? Just a poster pad on the routers. This one's going to be Adelaide. This one's going to be Elizabeth. This one's whatever. This PC1. But the ports are already labeled. But I'll show you that in a second. So host name, we're going to make this the ELZ dash RT1. Okay, so at least we know that's what it is. Okay. So first of all, interface gigabit, wasn't it? Gigabit 0/0. I think that's the one, but again, how do I know? Let's hover over it as well. There we go. It's gigabit 0/0. So, but you can't hover over a real router, so I don't recommend that. So like when you do this, it's almost like you're viewing the port that you're plugging in, okay? So that's the reason I do it like that. Yeah. So, sorry. Interface gigabit 0/0, like I said. And then we set our IP address of 192.168.30.1. 255.255.255.0 is the subnet mask. Yeah, I'm in the Elizabeth's site now. That's why it's good to have this on the side. Have an understanding of what you're doing. Where is it? Come over here. All right. So, and don't forget the no shutdown. And obviously we haven't tested it, but we could go here now. Once this goes green as well, just like it's green here, we should be able to test it. So if we go to desktop, go command, and if we do IP config, we can see our own IP address, which is cool. We can see that's the gateway's IP address, so we can use that to ping 192.168.30.1. And is that orange yet? That's still, oh, yeah, it's green now. Green now. There you go. All right. So it's all good, all working. We're testing along the way. So I should have mentioned that as well, so that you test along the way as you do a part. You confirm that part's working. Then you know for certain in your head that's done. Where you go to troubleshooting, you go, oh shoot, I didn't test that. Maybe the problem is that it wasn't working properly. So it's not this part, that last thing I did. It could be the 10 different things that I did beforehand wasn't working. So let's just make sure we're doing the right thing. And we'll close this. We'll go to the desktop and we'll go to the command prompt and we shall ping 192.168.10.1 as well. And there you go. Okay, it's all working. We can be satisfied that it is working. So let's go back to the command prompt, the console, and don't forget this is at the Adelaide PC, but we're connected to the Elizabeth router. All right, so I think everything's done except for the serial connection. Okay, so I said I wasn't going to do the passwords again because I've already demonstrated it. You've seen it once, just apply again. Okay, so if I go to exits, because we're in the gigabit interface, we go to the serial interface. Serial 0/1/0. Again, if I'm not sure, I just check it. Okay. You notice that, You notice that I'm not a very trusting person, am I? That's because, like in real life, if you're troubleshooting something, if you're not sure about something, you make mistakes. So you heard of the term, you probably heard it a million times. To assume is to make an ass of you and me. That's in IT. That's very true. You cannot assume anything. That's why I test everything, I confirm everything, and I move on. That's best practice in my opinion. So serial 0/10. Okay, we're here. So now, because this is the other end of so this is the DTE end, it's not the DCE end, we don't need to worry about clock rate. We only need to do it at one end. If we do it on two ends, it actually breaks the system, okay? So we don't actually do it. So all we have to do is IP config, not IP config, that's Windows command, isn't it? IP address 192.168.20.2. 255.255.255.252 that we worked out, if you remember.
Yep.
No shutdown.
I'll put in slash.
I can't remember. I don't think you can with this command.
Oh.
Yeah. So I've changed it to up now. You notice that it went to up straight away. That's because the other side was up already. You notice that this, remember the other side was still down. So even though your protocol's up, but your interface is still down because the other end wasn't up. But you notice that both sides are up and both sides are green now. All good. All right, so now we've got our IP address, all those basic things configured. Remember we said we talked about routing protocols and routes? So right now we've got this network, we've got this network, and we've got this network, but I doubt we can actually communicate between the networks right now because we haven't done anything. We haven't set a static route. We haven't configured any routing protocols. So that's what we need to do now. So if we're on the Elizabeth router, let's go exit and we'll do the show IP route command. And we can see that there's some directly connected networks. Okay, no problems. There's a local interface on each of those networks. No problems. But if you notice that if we look at these codes, we have nothing besides the locally connected or local interface. So there's no static routes, there's no routes learned from anywhere else. But we've seen the link come up, but we haven't tested communication between the two routers, right? So just to show you, from a router, I can still ping. You see this? It's a different. It's a Cisco iOS, so you're not going to see the reply like the Windows operating system. But what you do see is these explanations. That basically means communication, reply. If you see dots, that means no reply. Okay, so I can confirm that the link between the two is working. And now, if you remember, one of the routing protocols was RIP, wasn't it? RIP, routing information protocol. So let's just do that. That's a very simple one. So we're going to, configure terminal. Anytime you want to make a configuration, you go to configuration terminal, and to turn on the RIP routing protocol, we go router RIP, and to make it version 2, we go version 2. And now what do? We tell it what networks we are connected to. So network. The first network we're connected to as Elizabeth is the Elizabeth LAN. If you remember that was /24. Oops. Yes, we don't even need to put the slash actually. That's the network ID. And the other network we're connected to is the sort of the serial network, serial link, isn't it? So that's actually 192.168.2.0. Sorry, no, I made a mistake, didn't I?
20.0.
It's a 20.0. All right, so I made a mistake, boo-boo. All right, so now I'm telling the RIP protocol, these are the networks that we are connected to. These are the networks we tell other people that we're connected to. Okay, exit. We're pretty much done with this one, okay? So don't forget, don't forget, so this is thinking I accidentally pressed the other thing. Control Z, Control C. We might just have to wait. Don't forget, so basically what we got is we got a running configuration. We need to not export it, but copy the running configuration and save it over the startup configuration. Okay, so while this is,
yes.
Sorry?
Export's correct, but it's the wrong code language.
Oh, I'm not sure what you mean by export because we're not taking out of the router.
Yeah, PowerShell uses.
Okay, sorry, yep, maybe, sorry, yeah. So it's copy run in configuration to startup configuration. That's the command here. So it's stuck in this mode. So we might just. It's timed out anyway. So what we do is we copy the running configuration to the startup configuration. So, but before we do that, let's just show the running configuration like we did before. Just take one thing, the host name, Elizabeth RT1. Okay. Show the startup configuration. There's nothing. That's basically what it's saying. There's 0 things in the startup configuration because it's never been configured. Okay. So we need to copy the running configuration to the startup configuration. And do you want to overwrite the destination file name is startup config? And that's yes, just enter. Done. Now, if we do this command show the startup configuration, you can see it's something there now. All right, so we will go and we'll do a reload command. So because in the actual test you'll be asked to do a reload, and if you haven't copied run to start, you'll just basically lose everything. Reload turns it off and turns it on again, like someone mentioned before. But if you don't have a proper startup configuration saved, you just have nothing again, which means you have to do everything we did just then again. And let's return. But you can see I've got already the Elizabeth router hostname command configured there. That should be fine. We go to the ENA and oh, I didn't set a password on this one. That's why. All right, that's fine. We do the same thing to the other one. So we'll go back here, console, go back here, terminal, go back here. So we do have a, so this was pass, a capital pass, WD1. Okay, remember we said that? ENA was password 1. Enable password was password 1. All right, so now we copy running to startup configuration and we do a reload. And oh, sorry, we didn't even do the rip on this one, did we? We didn't do the rip on this one, but we'll do it again. Sorry, we've reloaded already, so we just do it after the reload. We just remind me to copy the running to the startup again. So that's the thing. Don't jump the gun like I just did. Just have a clear idea in your mind what you're doing, what you're up to. And though I just said that, obviously I missed that. Okay, so configure T. That's where we do it. Router rip version 2. And the networks we're connected to, networks 192.168.10.0. And the other network we're connected to is 20.0. Oh, no. 20.0. I'm trying to do things too quickly now. And we will exit all the way. We will copy running config to startup config, and we'll do that. And we'll use the show IP route now to, sorry, I'm doing things too quickly. Show IP route. And now you can see there's an R popping up. You see that R? That represents RIP. So it's learning about the Elizabeth network on the Adelaide server now from the RIP routing protocol. That's how we confirm, okay? So now we test. So from the Adelaide PC, so that's where we are, we need to ping the Elizabeth PC and vice versa. In real life, the Windows firewall could be a problem. So if that's a problem, you might have to use a virtual machine, okay, inside the thing, because like I said, the firewall is meant to block things that you don't want. Oh, come on, firewall. So you can see it's turned on, okay, but it could also block ping. If it's blocking ping on these physical computers, then we have to use a virtual machine on those physical computers in place of the physical computer. That's nothing, not a big deal. That's what we just have to do. But if we make it a bridge network, it will be exactly as if it's that computer anyway. You get me? It's just on a physical computer. We can't control the firewall because the AD security is controlling it. On a virtual machine, we have full control of the virtual machine. Okay, so that was a key thing. The firewall can block pings, but if we find on the physical, that's why we want you to test it. Work out what's going to work, what's not going to work. If your firewall is blocking ping, you need to use a virtual machine instead. So let's. That's my router. That's the Elizabeth PC. Oh, look. Time out. Time out. Let's. Oh, now there we go. All right. So basically, now it's going to reply. So basically, this is showing me I've got end-to-end communication between these two, which means every bit of cable, every bit of IP addressing configuration and interfaces are all configured and running properly. Okay, if I couldn't get that ping, let's say I couldn't ping the PC, I would probably ping, if I couldn't ping the PC, I might just try to ping one step back. Router. If I couldn't ping the router, I'll go one step back, and that was the router's the serial interface. And if I couldn't ping that, I'll ping my router's serial interface. And if I couldn't ping that, I'll ping my router's internal interface, a LAN interface, if you like to put it. That's the other thing I didn't do, wasn't it? So basically, that's how I would troubleshoot. I'll try to ping right to the end, and if it's worked, beautiful. But if I can't, I'll go one step back, and work out where it broke, basically. Something else I didn't configure was like terminal. Let's just go interface gigabit 0/0. I'll just show you this description. So if you remember, like gigabit, that's not very descriptive. So Adelaide LAN int. Okay. So basically, that's giving me a description of the interface, so that I don't have to always think what was that connected to. If I have a clear diagram of what I want to do, easy. But if I get myself confused, the main thing people struggle with is they confuse themselves or get confused. Okay, what's plugged into what? Okay, so hopefully I've now demonstrated how we can do the configuration fairly quickly. So don't forget I did this quite quickly and I was explaining myself as I'm doing it. We started probably almost 20 past 10. You got 2 hours, but obviously you're working with a partner. It could be faster, it could be slower, because you only need to do half. Realistically, if this was your scenario, all I had to do was this half.
So that is roughly.
Who knows? You have to be prepared. Okay. So basically, if I change this scenario to something else, the commands I'm doing is not very much different. So let's say we had 3 routers instead of 2. Well, all we have to do is work out what networks it's connected to, use the RIP networks, whatever, and it just works, doesn't it? If I'm configuring the PC on a 3rd network, it's going to work, same method. It's just how many times do I do it? And what do I test afterwards? So really, the things you're going to be asked to do is not going to be too much different to what I've done here. The scenario could be a little bit different. The IP addressing could be a little bit different, etc., etc. But overall, if you can do this, you can, and you're smart enough or you have competency, you should be able to adapt it for different situations. It's not going to suddenly get you to do EIGRP or something like that. Okay, it's not suddenly going to tell you to do this and do that, but basically this is it. Okay, so we'll leave it there on the actual computer-based demonstration. So what we're going to do is the second part of the demonstration. Come over across here. So for the pack, you're going to get one of these because for most modern computers, you're not going to have a serial port. So you can see it's in a box. There's 7 of them. We have had a habit of actually disappearing. So I should be expecting 7 back at the end of the session. Okay, so it's a USB. I'm sure no one's have a problem plugging USB devices in. Okay, so just
plug in, then turn around.
yeah. Probably the first way was the correct way. So the main thing you guys are going to have a problem with, let's just pick these 2 computers. Alright, so we turn these computers on first of all. And this is a bit of a mess. That's not what I want you to have. So basically your cables are here. Your routers and switches are here. And I'll just point out what these things are. So you've got a switch, you've got another switch, and all these things with lots of ports are switches, and these other things are routers. So let's just pick this top bank, okay? Because we're trying to replicate what we just did just there. So these 2 routers will go Adelaide, Elizabeth, Adelaide, Elizabeth. And in the real test, I would just get a post-it note, and I would actually plug it in. Okay, so let's just clean up after the other people. This is not what I want you guys to do. I want you guys to be, polite etiquette is to unplug, wipe the networks, and so forth. Okay, so those computers are turning on, are they?
Yep.
Alright, so I might get you guys to help me and log into those computers for me in a second. But let's just connect the routers up together first of all. So if you remember, let's start with the one end. Let's start with the Adelaide PC. So if this was the Adelaide PC, we would have a network interface card, which is an Ethernet card there, right there. And on the wall, we'll have these banks of ports. These banks match up exactly to these banks. All right, so if you remember, there's A1 here, red. There's B1 blue, C1, black, and they match up to these ones. A1, B1, C1. So wherever we plug into here will come out of those things. So let's get a cable. So for this part is the Ethernet cables. So we'll get a blue one for the PC. It doesn't matter what color, to be honest, as long as they're straight through. The easiest way to test, see if it's straight through is to line up the connectors side by side. And if you look at the color combo, they should be exactly identical. Okay? So if they're identical, they're straight through. If they're odd, they're probably a crossover. All right, so let's plug this one in. So one side into the Ethernet port. So I remember what I said about the clips being broken. So you just have to push it in. And the other side, we'll stick with A1 for this one. All right, and so that's plugged into the cable. It's running through the wall. It's coming out of this A1 back here. We get another straight through cable. Yeah, and we patch this straight through cable from A1 to the switch. If you remember, I said that in our other demonstration, I like to put the devices on the first one and the PCs and that afterwards. So if you look at this, there's port 1, port 2, and basically this bottom one is port 2, the top one's port 1. So I'll just plug it into port 2 like that, and you notice that this is actually off. So it's not going to work if it's off. So on this side, it's actually got a power cable. It's over here. It's plugged, just checking it's plugged in. Yes, plugged in. Okay, so let's come over this side. And then and then it should be on. Let me just double check why it's not on right now. Have to use it?
No.
Oh, okay.
I won't
So,
touch anything.
so this whole cabinet is powered by that extension cable. It's not production, so it's not meant to be necessarily on all the time. As you can see, it's pretty loud. So I think the lecturer just turned it off because it's too loud. But now I can see some lights. All right, so I see some lights flashing away, which means it's powered on, and I can obviously hear it as well. But what I'm expecting to see is this number 2 light up. Okay, this number 2 link light up right here because it's plugged into port 2. So this is what I'm talking about with the real life situation, is that you're not necessarily going to get perfect cables all the time. I can see that it's probably still loading up. Now I might just give it a moment or two, but I might change the cables. Like I said, other students are using it. What's to say if they did work on playing jump rope with these things? Okay.
But it's still booting, I think.
Yeah. Alright, let's. I think now the ports are coming up sort of. You can see they turned amber, all of them. So it might be just booting up.
Green.
Is it green on number 2?
Oh, it's green on all of them.
All of them, still testing the ports basically.
Yeah.
So now it's very good on this side. Right. So also, you got yourself on good?
Yeah, just
Work.
work on the right side.
Okay, so on this side I can see there's a link light. And I can see there's a link light over there now. So it's just a timing thing. Okay, it just took time for the switch to be turning on. And you can see there's the amber light right now. Okay, so remember the amber light indicates it's learning the MAC addresses. So when it turns green and green, it's actually finished learning. And also, like I said, there's the amber light there that's telling me that it's a link light. So even if there's no configuration thus far, there's still a link light. Okay, so this is what's called a console cable. You can see one side is RJ45, one side is the serial connection. But like I said, most modern computers don't have a serial connection. But what they do have is a USB connection. So, sorry, buddy. What we do have is this thing we were talking about just before. So we'll just plug this in now. Plug this in. Sorry, wrong end. We'll plug this in first of all. So this one side is USB, one side is serial, and we'll plug it in, and we'll plug this side into the USB of the computer, and we plug this one in one of the other ports. Remember the C1?
Oh, so that's why it uses Ethernet.
Yeah, so it uses Ethernet, so we can, because it's all straight through, it just passes the signal straight through in, and then we might just for completion, for something, we'll get a light blue Ethernet cable. So these are straight through cables, so basically if it's straight through, it just passes wave signal in the same way through. So that was C1. So we'll go here, and we plug it into the console port. Yeah, it's at the back. So when the pass it through, yeah. The thing with the switches is that that one side, the ports are at one side. Hey, can someone stick that cable through? Yeah, I got it.
Yep, you got it?
Yeah, got it.
Yeah, because like I think most of them are switching to micro USB, but
Yeah.
I can actually see why they.
So it's plugged into the console port right here. You see how it's a little bit different than on the packet tracer, right? Yeah, so it's actually going over there. Okay. So guys, sorry. See, Scott, that's actually, oh, you've got it open for me. So we've got this putty, but before we can actually use putty, we've got to actually make sure that the USB device is actually there. So we go to a device manager. Hopefully it's automatically detected it. And let's have a look. Oh yeah, here it is, USB. And why am I looking looking for. No, that's the trust.
Would it be under network adapter?
Let's check that. Sorry, network adapter. No, it's not under here. It's usually under a USB device. Let me just quickly go through this. Something happened just then. Here it is. COM ports. There's the USB. It says COM port 5, doesn't it? Yeah. All right. So on the PuTTY or of any other terminal program, we select serial. That's what it is. And then here we go COM port 5. Then we click open. And there we go. We're connected to the switch. And we will go no to the initial configuration, and then we are at the same sort of iOS command prompt as we were over there. So we go ENA to get into the enable mode, and if you remember, we go configure T, configure terminal, and we're into the terminal configuration terminal. And if we remember, we use the interface VLAN 1, and we set an IP address of 192.168. So this is the Adelaide switch, by the way, okay? 10.2, 255.255.255.0, and no shutdown. And we exit this. We still with this. We'll do a host name of ADL-switch. We'll exit this, and we use the show IP interface, and we can add the brief so we don't have every bit of information. And if we look at this, we can see all the ports basically, and then we have where is it? Here it is, the VLAN 1. And the IP address, and it's up. Okay, so let me just see if I can. So here we have a Ethernet device. This is a real Windows computer, don't we? So let's have a look at Ethernet. So it's so the problem is these computers are used for normal class as well. So if we totally change the Ethernet IP address, if we don't change it back, someone's already changed it anyway. So if we actually go to 30.101, if you remember, that was our plan, and the gateway was 30.1. That's Adelaide's 10, isn't it? Yeah, you're right. So if this is Adelaide, it should be 10. So I got myself lost. That's the problem. Okay. Just so they have a clear head, have a clear plan. So LA was a 10 network. We start a command prompt, and we ping 192.168.10.2, wasn't it? Was the switch. Let's see if we get a reply. Yeah, there we go. Okay, so far so good. Just like what we did in the simulation. All right, so the next part. Oh, okay, that's not good. The next part was that the switch is connected to the router, isn't it? So again, that was Ethernet. Okay, so we get another Ethernet cable. Let's just get yellow. Get a blue one instead of the big one. We don't need it's not super far away. So we get Ethernet. We go to the port 1 that we said we were going to use for the devices, and we go to the Cisco router. You can see that on the label there's gigabit 01. That's gigabit 00 with the label right there. So remember we said we'll start with the 0, the first one. So we'll plug it in. And now, who's behind it? Patty? Yeah, can you unplug the console cable? Yeah. Yeah, that's okay. So remember, just like on the packet tracer, we unplug the console cable from the switch. We plug it into, see how it's blue? So this is the micro USB you're talking about? Yeah. But there's also a Ethernet port for that as well. And if you notice this, there's actually those the serial connectors that we talked about in the packet tracer. So, and you notice that this is off. We'll turn it on. And now it's going to start. You can see that that's learning. That's gone to that orange in that port 1. It's learning the MAC address of the router now. And not that it's actually connected, it's just learning the MAC address. It doesn't have an IP address yet. So now, if we go back here, you notice that I changed the console cable to the router, didn't I? I changed the console cable to the router. So what I do here, I'm getting this actually. Program load complete, entry point, run on. Let me just reconnect this. And that was 0, that was COM5. So oh, here we go. Load image. Still loading up basically the router. Remember we just turned it on? In real life it's not as fast as in packet tracer, because in real life it's based on the hardware, just like a computer, processing power, memory, all that kind of stuff. It's not going to be as fast as what's in the packet tracer. Yeah. All right. Yeah. Still going. So
It's faster than my router at home. So.
Oh, you got a router at home? So
No, not modem at home.
Ah, okay. And maybe just pause this at this point. So, like I said, we need the Alice router and the Cisco router and the Elizabeth router to be connected. That was with a serial cable. So just a short one will do for this. And if we notice that the size of the connections is very small. I don't think we have any of the old types anymore, so that's this thing here. But if you notice on the ends, one end says DCE and one end says DTE. So DCE is the clock rate. And so remember in our demonstration on the packet tracer, we were going to make the Adelaide router, the DCE. So we will plug it on serial 0. By the looks of it, that's what it is here, and we'll plug it onto the serial 0 of the other one. And that's it. I can screw it tight if I wanted to, but for our class, doesn't matter. We just unplug it afterwards. So for the router, if you remember, Elizabeth router, we plug that into the Elizabeth switch, and then we plug in the Elizabeth switch. It's yellow again, but I don't have yellow, so Elizabeth switch to the other computer. So we'll go here. And what's the one next to the other computer? What is it? B. So I think we use B1. Sorry, A as the
A2, B2, C2, G2.
Yeah. So we used A2 for that one. So now we'll go back here. Yeah. And then and I think that's almost it. But while Scott's plugging that into that one, and you can see there's a link bar already flashing, because this time we're not waiting for the switch to turn on from scratch. So now while that's happening, so Michael, maybe focus on the screen. We've got our finished loading. So this is the initial setup. Do I want to set it up with the basically getting initial configuration? I'll go no. Come on. Why does it take you so long? Yeah, here we go. No. Okay, let's. Oh, come on. All right. So this is what I'm saying, like on a real live device, there's a lot more to consider, and this is good. Maybe I'll configure the IP address of this computer while we're at it. So we'll configure the IP address while we're waiting for that again. So Ethernet, change adapter options, and there we'll go properties for the Ethernet connection, IP TCP IP version 4, and it was 30, wasn't it?
Yes.
And it was 101. And the gateway was 30.1. Okay. Just confirm that. Nope, didn't change. There was error message. If you noticed, did I make an error? What was it? 192.168.30.101. 192.168.30.1, and we'll click OK to that again. Not all your request changes could be made. No, it didn't change. That's a little bit unexpected. So we might just change the DHCP and see if that.
Is everything all turned on?
It's not so much that. This is a Windows problem. So it's a problem with this computer. It's not to do. It's not nothing to do with the switches and whatnot. Okay, so this is a error that's not normal. Let's give it one more shot. Let's actually do one more thing. Disable. Enable. That's basically turning off and on again the interface. Now it's trying to identify, and it's got that still, but let's see if we can change it. We'll change it to DHCP first of all. No. Alright. So for some reason this is a bit this is locked. I don't want to spend too much time troubleshooting this, but you notice that this is 29.3 and 29.1, so we'll just change our settings to reflect those, or we could just use a different computer, or we could use a virtual machine. No, look at that, it's actually getting out. That's the Wi-Fi network, so this is that one. Okay, so let's go back here. Right, so Michael, so if you want to have a look at this, this is getting back to that router prompt now, and we'll just go enable. First thing we'll do is we'll configure the host name. Oops. And host name was ADL-router1, if you remember. And we've got two interfaces, the gigabit and the serial, wasn't it? So I wasn't sure. Remember what I kept on checking? What I checked was this label. So I'm going here and checking the label is gigabit 00. So that's gonna interface gigabit 0/0 and IP address 192.168.10.1 255.255.255.0 and no shutdown. Oh, sorry, no space. Alright, no shutdown. Exit. The other interface was interface. It's trying to bring it up, by the way. And obviously, while we're at it, so this is where we can actually ping .1 and confirm that it's actually working. It's not ping, but as we learned from the other thing, let's actually have a look. Okay, so let's exit this. Show IP interface brief. Alright, so gigabit 00 is 1, it's up, gigabit, frontier, that's all good. Let's try one more time. There it goes. It's just a matter of, I changed nothing, by the way, didn't I? It was just because it was learning the MAC address again. But it just took a little bit longer. So on the real thing, it's not as straight away as the simulation. So so far so good, all good. So if you remember, the other interface was, we'll go back to the configure terminal. The other interface was the serial interface, wasn't it? Serial 00. I keep on forgetting. So if I read this as 0, yeah, it should be 0, 0, 0, because it's on eWIC 0. It's the serial 0. Oops. Alright, so IP address one 192.168.20.1 255.255.255.252, if you remember from our scenario before. And we go no shuts down. Oh, sorry. Remember the clock rate? Clock rate 56,000. No shutdown to keep it up. Alright, exit. And we want to turn on router RIP. Remember the RIP protocol? So I'm not going to do the encryption of passwords the same over there as it is here, or setting the passwords exactly the same, but we just want to show that it's working on the computers. Okay, so router RIP is turned on, version 2, and the networks that we know about is 192.168.10.0 is the LA LAN, and the other network is 20.0, which is the serial network, and that's all it is. Exit. Control Z takes us all the way back, by the way. So I think that's done as far as we need to do it now. Obviously there's that passwords and encrypting the passwords and all those kind of things. All those kind of things as well, but obviously I demonstrated that before. So what we want to demonstrate now is just so that we can set an IP address on the real thing, configure router RIP on the real thing, and then we see if it works on the real thing. So again, we've got the same serial cable, and we should have turned this on. We should have turned this other router on probably earlier. Would have saved us a bit of, so too bad. So we unplug this console cable from that router into this router. You notice I'm just using the same console cable one at a time, configuring one at a time. I don't need, just because I've got 4 devices, I don't need 4 console cables. Okay, just one's enough. And then when we get back here, you can see it's actually loading as we speak. And unfortunately, this might take a few moments as well. So like I said, because of this computer being stuck on that networking, I didn't want to spend too much time messing with it. We're just going to adjust our Elizabeth network to 192.168.29.0, and everything is adjusted. Remember, instead of 30, it's 29 now. Alright, so you might want to pause this. So, all good? Mm-hmm. We're on to the, you notice our Elizabeth router is now loaded. Gone to the initial configuration. I'll press no. But if you remember last time, this took a little bit of time after this as well. And unfortunately, it's just, that's the realities of life. Here we go, it's loading. Hopefully we can get this done before the end of the class. But if we can't, we'll just go a little bit over and we'll come back a little bit later. Okay?
12 minutes.
What did you say? Coconuts?
12 minutes.
So we've got 12 minutes to get it done. I feel like I'm under pressure now. So 12 minutes, if we don't get this done, it's going to explode. Where's their Mission Impossible theme song? Alright, let's... You recording?
Yeah.
Alright, cool. So we're onto the router prompt now, so it's we can tell by the pointy brackets. Now we'll go to enable, we go to configure terminal, and we go to the interface gigabit 0/0, if I remember correctly. I would check, but I'm under time pressure now. 192.168. So this is the Elizabeth router. So if you remember, we made that adjustment that it's 29 now because of that computer. All right, no shutdown. All right, so getting back to here, to this other computer, which is the Elizabeth PC. Now that it's coming up, we should be able to ping 192.168.29.1 if everything else is working properly, because there was a little bit of a problem with the interface, but let's see.
RIP.
No, we don't need RIP to ping the local interface right now.
Oh, right,
Yeah.
yeah. No, I'm
Let's see what's going on. Alright, we might just check it another way. This PC I don't fully trust, so that's done. So the other thing we have to do is the serial interface. So interface serial 0/0/0. IP address is 192.168.20.2. 255.255. Dot 252, and this was on the DTN, so no clock rate required, no shutdown. Exit. We'll do the router RIP now. Version 2, and the networks we know about is 192.168.20.0. The other networks we know about is 29.0, and we will exit and we will show IP route, and what we got here is this R, if you notice. Okay, this R, which represents we're learning about this network through the RIP protocol. So I don't trust this PC, but we can, like we said, we don't have to ping all the way to this PC to show the routing is working. So if we go to the command prompt here, remember this is on the Adelaide. So instead of pinging all the way to the PC, I'm going to ping all the way to the router interface on the Elizabeth network, and hopefully yeah, we'll go back one step. Yeah. So if this is not going to ping as well, we'll go back one step to 0.1. No, actually. So we did ping the router, and so what I'll get you to do, Scott, is can I get you to plug in the console cable to the Adelaide router?
So this one here?
The one that's plugged into the console port?
So, yeah.
and plug it into the console port of the Adelaide router. So basically so if you look at that, that's the Adelaide router now. Enable, show IAP route, and we're definitely learning that one. And this IP config. Let's have a look at this. One, I have a feeling it's I have a feeling because we've got multiple interfaces here. We've got the Wi-Fi interface as well, which is connected, and we've got this one that's this physical machine. It's got a couple of
Can I
extra
pause for a second?
Yeah, sure. One is we plugged in the actually C2. So A2. Was it A2 or C2? A2.
A2.
Yeah, A2, and that's plugged in a switch. No, that's computer plugged in.
Is it plugged into the correct switch?
But is the switch plugged into the router?
The switch. So this one is. Sorry. This is this one. That's that one. This is plugged into a router. No, it's plugged in. So that's plugged in, which is over there. But this goes to A2, which is coming out of there and into the back of the computer.
Has the computer got the interface working? Is it showing your status?
Yeah,
Well, it's
that
got a
one's
link
shown.
light, so that's thingy. But let's let me just check this out. Yeah, now it's working. So continue recording, please. So basically what I just did was, because this real computer's got multiple interfaces that has gateways, it doesn't know which one to use. Okay, so I've actually disabled the Wi-Fi interface as well as the VMnet A interface. If you remember, that's the virtual network interface, which is on a NAT network, which also has a gateway. So basically the only one that has a gateway left now is the Ethernet interface. You get me? That's the only gateway we can do something. So it was getting confused. I've got too many driveways out of my house. Too many doors out of my house. Which one do I use? Okay, so basically now, if you look at this, I'm pinging the serial interface of my router. I'm pinging the serial interface of the Elizabeth router. I'm pinging the Elizabeth LAN interface. All good? And let's just go one more step. I know that was a little bit problematic, so I don't miss it. Oh, it's not 29, it's top 3. So, top 3, if I remember. Alright, so I don't expect this to work because this computer's got a little bit of problems, and if it was a real practical test, I would download a virtual machine in place of this. But I would probably use virtual machines on both, to be honest. You have less problems. In a virtual machine, you don't have these physical interfaces that get in the way. Remember I said how there's multiple gateways? Well, which one do I use? But if I have a virtual machine, there's only one interface card, one gateway, so there's no confusion. So I will re-enable these because we need them for normal networks, normal functionality of this computer. So that's the one thing we don't want to mess up. We don't want to mess up it being used in the next class. Even though we're here on the next class, we don't want to mess it up for those people. So like I said, let's have a look at the C drive. Well, here it is. Do we have no virtual machines here? But if I were a student and I want to just minimize the problems I'm going to have, I'm just going to download a Windows 10 virtual machine and put it on my C downloads folder, and hopefully that doesn't take too long.
Do we have to use these computers during the crack, or could we
you can use virtual machines. You have to be here on this side because that's where the ports
Until we use our laptops, for instance.
no, you can't use your laptops because I don't know what's on your laptops, first of all. So this is just the standard equipment, but I will recommend that you're using the physical ports here, but you're using virtual machine instead on both of these computers. And these virtual machines have to be configured with the bridge network and has to be bridged with the Ethernet interface. So let me see if there is a virtual machine here. That's PC1. That's zipped. So okay, maybe I shall. Yeah.
They're deliberately broken.
Oh, they're deliberately
We're in that
broken.
class.
Okay, so we won't use those ones then. All right, so just pause it there. The virtual machine. Let me just create a new virtual machine. I'm not going to install the OS or anything, but let's just pretend this is the virtual machine with an OS already. Let's just put it there. Finish. All right, let's just pretend this is the virtual machine that you've downloaded, and it's all got an OS and everything. We just need to make sure that this network interface card is bridged. Okay, bridged means uses the physical network card. And the second thing is that we need to make sure that the bridge network is actually bridging. So we'll click change settings. And the bridge network is actually using the Ethernet adapter. See how it says automatic? Which one is it using if it's automatic? If we drop it down, we can see that it's the Realtek gigabit interface on these computers. It's not the Wi-Fi network, it's not the Bluetooth, whatever. It's the gigabit. And that ensures that you're using the physical network Ethernet adapter that goes through these cables into the thing and into the routers and switches. Okay, so that's critical if you're using a virtual machine to know that. You learned that through for IBM, right? We're all good with that? Getting back to this packet tracer demo that we were using, I think the question was, Scott, what was this question before we left?
The erasing of all the conflicts and all the devices.
Yeah, so basically, when we finish with the physical devices, because other people are going to use it, we need to make sure we follow the, the courteous lab behavior or etiquette. So basically, we need to unplug everything, put the cables back where you found them, okay, which you've done for me, Michael, which is good. Appreciate it. The other thing is that the routers with your configuration, obviously, other people want to have a go. They don't want to know your passwords, or they may not even know your passwords, especially if you don't use the default passwords. So we don't want to make it any harder for the next person doing the test, and you probably want the same thing for you. So the question was, how do we erase it? Okay, how do we erase the configuration? So it doesn't matter if it's a Cisco. It does matter depending on if you're doing VLANs. So obviously we did the VLAN 1, which is the default VLAN, not a big deal. But if we're working with VLANs at a high level at the next Cisco subject or something, there's more to do. Yes, it should be. Thank you for reminding me, Michael, actually. I was just looking at my screen here. But thank you for reminding me. So we'll just so with the switch and the router, it's the same command, and we would just do it on every Cisco device that we've done. So the other thing is, on the PCs. So we've obviously, if we were messing with the physical PCs, and we set an IP address, okay, obviously that's not going to work in the normal class situation. I know they got the Wi-Fi's and whatnot, but if they were set to DHCP and set to automatic previously, and with the interfaces set to DHCP automatic, put it back to that. First thing to do, okay? So if they were, put it back to the same configuration that you had before, which is DHCP instead of static for the PCs. For the routers, so if you look at this, I've got the desktop, I've got the terminal still going, connected to the Adelaide router. So again, we go to enable mode. password for it. And then if you remember, we have the startup configuration. So that's where the configuration is stored when the router goes offline. So that's what it is loaded up the next time it comes online. The running config is just in memory. So that's just dispatched with during if the power goes off. So really it's the startup configuration we need to mess with. So we use the erase command. So Scott, you asked this question. So we use the erase commands just as you probably think. Startup config. And do you want to confirm this? Yes. And now, so it's basically, I think that's what it says, initialize the geometry of the NVRAM. Remember the NVRAM is the non-volatile RAM. Volatile means it changes. Non-volatile means it's kept. So what we can do is, if you notice this host name for this router is ADLRT1. We would then, after we've done the erase, we do the reload command. And do you want to save it? No. Okay. We don't want to save any configurations because that's the whole point of what we're doing here. And we will confirm the reload. And then it's going to basically, it will take a little bit longer on the real routers, of course, but this is after you test, after your practice. So it's not going to count towards. So then it would go, when it reloads, it'll go to that initial configuration. And if we choose no, you'll see that the router prompt is gone back to the original, the default. Okay. So again, we want to do this for every device we've configured. So just to show you the same thing again, terminal, okay, log in, enable, erase. So easy. What we're erasing the startup config. Yes. And then we reload. And we reload. And basically it should have the easiest way to check if you configure the host name. It shouldn't say whatever host name it says. It should just say, it should come up with this initial configuration again. And you'll say router or switch, whatever. So that's what we've done. I don't think I've configured this switch, so I'll unplug, plug into this one, just so you know it's the same thing. Go here, go here, go here. Now we're on the Adelaide switch. Again, to enable, erase, startup config, confirm, reload, and no to the saving the modifications, confirm to reload, and just when it finished reloading, confirm that the host name at least, or you get that initial configuration, yes or no. Let's have a look. All right, so it's gone back to switch, if you notice that. Okay, so that's all it is, guys. So it's just a erase. What do you want to erase?